Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we go through the area of triangles and kites. So let's start with the area of a triangle. So obviously a triangle is any three-sided shape. So if we look at this triangle on your screen, I'm going to call the base B. B just means the length of the base, just like it did when we were doing parallelograms. So it turns out if I draw a rectangle that encloses this triangle, just so that the top of the triangle hits the side of the rectangle, it turns out that the area inside the triangle, this area here, is exactly half of the area of this whole rectangle. So if I allow the width of the rectangle to be called h, the area of the whole rectangle is just b times h. It's just length times width. So the area of the triangle will be base times height divided by 2. It'll be the area of the rectangle divided by 2. Now, the reason I called it h is because h is this distance here that is perpendicular to the base. So remember when we were doing parallelograms, I said whenever you see a h in an area formula, it always means perpendicular height. So for a triangle, we calculate its area by multiplying the base by the perpendicular height and then dividing by 2. Don't forget to divide by 2. So let's look at some examples. So let's find the area of each of these three triangles here. So starting with this one. So it's base times perpendicular height divided by 2. In this example, 10 centimeters, which is the slant height, doesn't actually factor into our calculations. So the area is just 6 times 8, base and perpendicular height multiplied together, divided by 2. Of course, it doesn't matter the order, whether you do 8 times 6 or 6 times 8. So if you put that on your calculator if you need, you get 24. And because measurements were in centimeters, it's centimeters squared area. So let's look at this triangle here. So it's base times perpendicular height divided by 2. Once again, we don't need the slant height. This doesn't enter our calculations. So we just go base times perpendicular height divided by 2. The answer we get is 60, and in this case, it will be meters squared. So let's look at this last one here. So it turns out when you have an obtuse triangle, the perpendicular height needs to be drawn outside the triangle. So once again, the slant height here does not enter our calculations. The area of this triangle is base times perpendicular height, and always remember to divide by 2. A lot of people forget that step. And so I can forgive you for using your calculator for this, and you get 197.925. And of course, because the measurements were in millimeters, the area is in millimeters squared. How easy is that? So now we're going to look at using the area of a triangle to find one of its sides. So let's do this question here. Area of a triangle, 40 centimeters squared, base 5 centimeters. What is the perpendicular height? So let's start by drawing a triangle here. So we're told area is 40 centimeters squared and the base is 5 centimeters. We're finding this height here, the perpendicular height. Now, a lot of people tell me the answer is 8 because 5 times 8 gives 40. That's not right, because remember, when you're finding the area of a triangle, you times the two things together and divide by 2. So what we're saying here, this height here, when I times it by 5 and then divide it by 2, I get an answer of 40, right? So what that means is the base times the perpendicular height here actually has to equal 80. So the height times 5 equals 80. So the reason for that is we need to go 5 times height to give 80, so that when we divide it by 2, we get our final answer of 40. So we're saying, what do I times by 5 to get 80? Well, that's easy. That's just 80 divided by 5, which is 16, and in this case it would be centimetres. So then we'd go 5 times 16 is 80 divided by 2 gives 40 centimetres squared, and we're done. Let's now look at finding the area of a kite. Okay, let's look at finding the area of a kite. So a kite is also known as a diamond. It has that diamond shape. So a kite is a quadrilateral. It has 4 sides, unlike triangles, which obviously only have 3 sides. So kites have the property that adjacent sides are equal. So those 2 sides will be equal, and these 2 sides will be equal. So we're actually going to use the area of a triangle to find the area of this kite. I'm going to divide it into 2 triangles like this. So let's call this length here B. I called it B because it's like the base of this triangle and also the base of this triangle. So the area of this kite is just going to be the area of the top triangle plus the area of the bottom triangle. So let's call this distance here the perpendicular height. This time I'm going to call it A. Now, it just turns out that because of the property of a kite, if this distance here is A, the distance from the center up to here is going to be the same. It's also going to be A. So what I'm going to do is calculate the area of this triangle here. So that's just going to be base times perpendicular height. This time I've called the perpendicular height A over 2. That is the area of this triangle here. The area of this triangle here is actually the same. These 2 triangles have the same area. So it will also be base times perpendicular height over 2. So if I add these together, I have half of AB plus half of AB. I just get AB. So that would actually be the area of the kite. It's this length here times this length here. We don't need to divide by 2 because there are actually 2 of these triangles. So that is how you find the area of a kite. Now, another easier way to look at it would be, well, this length here is B, obviously. But this length here would be A plus A, which is 2A. So I can multiply B by 2A and divide it by 2. You're probably thinking, why did I write it like this? Surely this is more complicated. Well, this diagonal is B. This diagonal is A plus A, it's 2A. What I'm saying, all of this is getting at, to find the area of a kite, all you do is multiply the 2 diagonals and divide by 2. That's what this is saying here. It's taking this length, multiplying by this length, which is 2A, and then dividing the answer by 2. Because B times 2A divided by 2 just equals AB, which we figured out before was the 2 triangles added together. So here we have a poorly drawn kite, sorry about that, and we're going to find its area. So I'm telling you, this distance here is 6 centimetres, this distance here is 15 centimetres. So we call this length here and this length here the diagonals of the kite, even though they're not diagonal lines. Diagonal just means it joins vertices that are not next to each other. So it joins these 2, this length joining those 2 is 6, this length joining those 2 vertices is 15. So the way you find the area of a kite is you times together the 2 diagonals and you divide it by 2. 6 times 15 divided by 2 gives us 45, and of course we're area, so it's centimetres squared. So let's look at this kite here. So to find its area, here I've given you one diagonal is 8, but this distance here is just half the diagonal is 3. So that means that the full diagonal here would be 6 again. So the area of this would be 8 times 6, multiply together the 2 diagonals and divide by 2. So that just gives us 24, and of course the answer is in meters squared. So it's really easy for a kite, just multiply together the 2 diagonals and divide it by 2. So I'll point out that this is also how we find the area of a rhombus, because a rhombus is a type of kite. It's a special type of kite that has all four sides equal. A common misconception is that if you have a four-sided shape with all sides equal, then it must be a square. That's not necessarily true. A rhombus is basically a square that is slanted. So a rhombus has all four sides equal and is a type of kite. So the way we would find the area of this rhombus, we just use the area of a kite formula. It would just be two diagonals multiplied together and then divide by 2. So the answer we get here is 22.5 millimeters squared. So we're just going to do now one quick example where we use the area of a kite or rhombus to find one of the diagonals. So let's try this question here. The area of a rhombus is 35 centimeters squared, one diagonal 3 centimeters longer than the other, and we want to find how long is each diagonal. So this is quite a tricky question, but let's start by drawing a diagram that will hopefully make this easier. So a rhombus is a type of kite. Remember, it has all four sides equal. So remember, the area of a rhombus or kite doesn't depend on these side lengths. We don't even need to know them. It only depends on the two diagonals here. So we have one diagonal and another diagonal. So remember, when we find the area, we multiply these two diagonals together and divide by 2. So the length of the two diagonals, they must multiply in this case to give 70, because we then, after multiplying them, divide by 2 to get our area. So we need two numbers, two diagonals that multiply to give 70, so that when I divide by 2, I get 35. So I want to find two numbers that multiply to 70 where one is 3 centimeters larger than the other. So unfortunately, all we can do here is use trial and error, but because you're really smart, it won't take long. We just go through factors of 70. So 70 and 1, well, that won't work because 70 is more than 3 centimeters more than 1. So 35 and 2 won't work, but it turns out that 10 and 7 will. So we just go through the factors of 70. One diagonal will be 10 centimeters, one will be 7 centimeters, because then this one is 3 centimeters longer than this one. And if I say that this diagonal here is 10 centimeters and this is 7 centimeters, the area of this rhombus will be 10 times 7, which is 70, then divided by 2, which will be 35 centimeters squared. How easy is that? So remember that you always divide by 2 when you're finding the area of a rhombus or kite or a triangle. People often forget that. All right, thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.